audio lesson for chapter 11, lesson 4 for science, energy, and Earth's atmosphere. How does energy from the sun travel to the Earth? Nearly all the energy in Earth's atmosphere comes from the sun. This energy travels to Earth at electromagnetic waves, a form of energy that can move through the vacuum of space. Electromagnetic waves are classified according to their wavelength, so their distance apart, and the distance between wave peaks. Most of the energy from the sun travels to Earth in the form of visible light, so we can see the heat, and infrared radiation, so you can feel the heat. A smaller amount arrives as ultraviolet radiation. Page 393. You can see visible light. Visible light includes all of the colors that you can see in a rainbow. Roy G. Biv, red, orange, yellow, green, blue, and violet. The different colors are the result of different wavelengths. Red and orange light have the longest wavelengths, while blue and violet have the shortest wavelengths. So what it's saying is these wavelengths in red and orange, they're wider, they're farther apart. And then the wavelengths for blue and the purple are closer together. Non-visible radiation. The direct transfer of energy by electromagnetic waves is called radiation. One form of the electromagnetic radiation is infrared radiation. Energy is infrared radiation, and wavelengths that are longer than the wavelengths for red light. Infrared radiation is not visible by humans, but it can be felt as heat. The sun also gives off ultraviolet radiation, which is the UV rays, which is an invisible form of energy with wavelengths that are shorter than wavelengths for violet light. Ultraviolet light can also cause, ouch, sunburns.
That had like 70 times.
394. What happens to the sun's energy when it reaches Earth? Sunlight must pass through the atmosphere, whatever ozone layer that was yesterday that we read about, before it reaches Earth's surface. The path of the sun's rays shown in figure 2. Some sunlight is absorbed or reflected by the atmosphere. Therefore, before it can reach the surface, the rest passes through the atmosphere to the surface. They talk about the upper atmosphere. The ozone layer, was that in the stratosphere yesterday? We learned about that. But the upper atmosphere is different wavelengths of radiation are absorbed by different layers. For example, ultraviolet radiation is absorbed by the ozone layer in the stratosphere. Infrared radiation penetrates further into the atmosphere before it's absorbed by water and carbon dioxide. So that would be reaching all the way down to the troposphere, just like in that picture on 340 and 394. 395. The troposphere. Clouds act as mirrors, reflecting sunlight back to space. So that's cool. Dust-sized particles and gases in the atmosphere disperse. They spread out light in all directions, a process called scattering. When you look at the sky, the light you see has been scattered by gas molecules in the atmosphere. Gas molecules scatter short wavelengths of visible light, blue and violet, more than the long wavelengths of red and yellow. Scatter light looks bluer than ordinary sunlight. That's why clear daytime sky looks blue. Exciting. Earth's surface. It may seem like a lot of sun's energy is absorbed by gases in the atmosphere or reflected by clouds and particles. However, about 50% of the energy that reaches Earth's surface is absorbed by land and water and changed into heat. Look at figure 3 to see what's happens in upcoming sunlight at Earth's surface. So they're telling you on the bottom, if you want to look at that picture, 5 to 10% is reflected when it hits the asphalt. 80 to 90% is reflected when it hits the snow. So the different mediums on the bottom show the different reflection. We're going to skip 196. You can read this and do this on your own if you're interested, but we're going to finish reading on 397. Earth's energy budget. What happens to the energy that heats the land and water? Earth's surface radiates some energy back to the atmosphere as infrared radiation. Much of the infrared radiation doesn't immediately travel all the way back to space. Instead, it's absorbed by water vapor, carbon dioxide, methane, and other gases. The energy from the absorbed radiation heats the gases in the air, and these gases hold heat in Earth's atmosphere in a process called the greenhouse effect. So it gets stuck here in the gases. The greenhouse effect is shown in this figure. It's a natural process. It keeps Earth's atmosphere at a temperature that is comfortable for most living things, such why they have greenhouses. Over time, the amount of energy absorbed by the atmosphere and Earth's surface is in balance with the amount of energy radiated back into space. Earth's average temperature remains fairly consistent, which is good. We need it like that. But scientists have evidence that human activity is altering the process.